Hello. In this video, we will talk about the geometric applications of the system of linear equations. Before going to the geometric insight of the system of linear equations, we will first consider the system of linear equations with more equations than unknowns. Suppose there are m equations and n variables, and we are assuming that the number of equations are more than variables. So we are assuming m is greater than n. So if the number of equations are more than the number of variables, what we will do, we will reduce some equations and we will make the system square. Since this system is non-square because the matrix obtained by these equations, m equations with n variable, is m by n. So that means this is not square matrix. For the square matrix, m and n must be equal. So what we will do, we will drop some of the equations from the last because equations are more than variables. So we will drop some equations and then we will solve the system using the Cramer's rule. After solving the system using the Cramer's rule, we will check whether the remaining equations satisfy those solutions or not. If the remaining equations satisfy those solutions, we will say that the system is consistent and it has a unique solution. If the remaining equations do not satisfy that solution, that means we will say the solution is not congruent, solution is not valid. And geometrically, we will say that each equation is geometrically just a line. For example, if you have three equations, that means we have three different lines. You can check these lines are intersecting at these three different points. For a system to have solution is geometrically means that the three lines, for example, they will meet at exactly one point. This is not the case. If this is the case, that means the system has no solution because they are meeting at three different points. In order to have a solution, they must meet at the single point. For example, if you have this line and this line, the third line must cross this point. Third line, wherever it is, it must cross this point. If these are the three lines, they are meeting at one point, one and only one point, then we will say that those three linear equations have solution. Otherwise, we will say they have no solution. This is the geometric insight. Let's do an example. In that example, we will have three different equations and we will solve them, and we have two variables. So we will have three different equations with two variables. So here is the system of linear equations, and you can check we have only two variables, x and y, in each of the equation. You can check. Here you also have two variables. So we have two variables and three equations. So this is the case. We have more equations than number of variables. Okay. So we have three equations and variables are two. Since 3 is bigger than 2, so we can use this fact. What we have to do, we will reduce our equations. We will make equations equal to the number of variables. Since variables are 2, we will pick only two equations. Either we pick the first two equations, or we pick the last two equations, or we pick the first and last equation. It doesn't matter. So what we will do, we will pick the first two equations and we will make our system square. Because this matrix needs to be square matrix in order to solve using Cramer's rule. So we will first pick the first two equations to make our system square. Because this is non-square system, we will make it square. Okay, so let's consider only first two equations. Okay, so we have considered the first two equations and now we will solve them. In order to solve these equations, we will write these equations into the matrix form. You can check here the matrix A, which is the coefficient matrix, is 1, m, 2, and 6, because the coefficient of x is 1, the coefficient of y is m, and here the coefficient of x is 2, and here 6, the coefficient of y. Okay, and what is b? The matrix b, the constant matrix, is this one, 1 minus m. So I will write 1 minus m. Okay, what is Cramer's rule, and what is X matrix? The matrix X is x comma y. Using Cramer's rule, we can solve it because x is equal to the determinant of a1 over determinant of a, and y is equal to determinant of a2 over determinant of a. So we will find the determinant of the matrix A, and then we will find determinant of a1, and then we will find the determinant of a2. So let's first find the determinant of a. What's the determinant of a? The determinant of a is just the product of these two minus the product of these two. So 1 times 6 minus 2 times m. So if I solve it, it is 6 minus 2m. So this is the determinant of a. We know that the system has unique solution if and only if the determinant is not equal to 0. Okay, so we will say the system has solution if and only if the determinant is not 0. I mean, this is not equal to 0. 6 minus 2m is not equal to 0. What does that mean? 2m is not equal to 6. I mean, if I take this 2m here, it will be 6 is equal to 2m. I mean, not equal to 2m, because here we have unequal. So if I divide both sides by 2, I will get m is not equal to 3. So the system is valid for m is not equal to 3. I mean, you can take every value of m, but you cannot take m is equal to 3. You can take any value of m, but 3 is not possible. If m is 3, then this system has no solution, because then in that case this determinant will be 0 and the system will be inconsistent. It will have no solution. So we have two different cases. Okay, case 1 when m is equal to 3, and case 2 when m is not equal to 3. Because in the given system we are not given m can be 3, m can be not, n can be other than 3. Okay, so we will check what will happen if m is 3. I told you if m is 3, then the determinant will be 0 and the system will have no solution. When m is not equal to 3, then the determinant will not be 0 and the system will have solution. Make sense? Look at the first case. If m is 3, then what will be our system? Our system is x plus my equal to minus 1, 2x plus 6y is equal to minus m. But if I put m is equal to 3 here I will write 3 instead of m. Here I will write 3 instead of m. Okay. Since we know that for m is equal to 3, because 3 came from here, for putting is equal to 0, if m is 3, then 2 times 3 is 6, 6 minus 6 is 0, that means the determinant will be 0, so the system will have no solution. So we will say no solution, because determinant of a will be 0. So in this case there is no solution. Now we are interested in the case where we have solution. Okay, if m is not equal to 3, then what is the determinant? The determinant is 6 minus 2m. Since m is not 3, so that means it cannot be 0, because you cannot put here 3. When you will not put here 3, then 2 times any number other than 3 will not make 6. So 6 minus the number other than 6 will not be 0, so it cannot be 0. So when the determinant cannot be 0, that means the system has solution. When the system has solution, then we can use the Cramer rule. Since the determinant is already found, now we will find the determinant of A1 and the determinant of A2. You know that the determinant of A1 can be found by replacing the first column by the matrix B. Okay, and the determinant of A2 can be found by replacing the second column by the matrix B. Okay, so first of all, I will find the determinant of A1 by replacing the first column by the matrix B. Okay, so this case is done. Now we are dealing with this case. Okay, since the determinant of A1 is obtained by replacing the first column by the matrix B is minus 1 minus m. So I will write minus 1 minus m here, and I have to find the determinant. What's the determinant of this matrix? It's just the product of these two, negative 1 times 6 minus the product of these two, minus m times m. What is this? If I calculate these values, it is minus 6 plus m square. So the determinant of A1 is minus 6 plus m square. Similarly, the determinant of A2 is just obtained by putting matrix A, but its second row will be replaced by a matrix B. Since the matrix B is minus 1 minus m, so I will write here minus 1 minus m. Since I need the determinant, so I will write the determinant. And the determinant of this matrix can be obtained by the product of these two, which is 1 times minus m minus the product of these two, minus 2 times minus 1. Minus m plus 2. Okay, so the determinant of A2 is minus m plus 2. Now I can easily find the value of x and the value of y. The value of x is the determinant of A1 over the determinant of A. What's the determinant of A1? It is minus 6 plus m square. So I will put here minus 6 plus m square. Over the determinant of A is 6 minus 2m. So I will write here 6 minus 2m. The y value is the determinant of A2 over the determinant of A. Since the determinant of A2 is minus m plus 2, so I can write here minus m plus 2 over the determinant of A is again 6 minus 2m. So I have found the value of x and y. Okay, look. Initially, we had 3 different equations. We had only solved the first 2. Okay, what we have to do with the third equation? We have solved the first equations and we got 2 different values, x and y. So in order to have unique solution, the solution for the first 2 equations must satisfy the last equation also. Since we did not consider the last equation, what we will do, we will copy this equation and we will use the solutions from the first 2 equations and put those solutions in the last equation. For example, this is the last equation and these are the solutions obtained by first 2 equations. So what will I do? I will put these solutions in the last equation. Since this is the value of x, this is the value of x because it is equal to x, and this is the value of y because it is equal to y. So here in this equation, in place of x, I will put its value, and here in place of y, I will put its value, and I will check whether these values satisfy the last equation or not. So I will write m times x. The value of x is this thing, which is minus 6 plus m square over 6 minus 2m. So I will put its value. So m times x plus 9 times y. The value of y is this. So I will take the same value and put in place of y. in the last equation, and this is equal to 4. I will write here 4. Now I'll multiply m inside, so I will get minus 6m plus m cube over 6 minus 2m, plus I will multiply 9 inside. I'll get minus 6m plus 18 by 6 minus 2m is equal to 4. Since both terms have the same common denominator, which is 6 minus 2m, so I will write 6 minus 2m because it is common denominator. Then I will add the numerators of both, which is minus 6m plus m cube plus this denominator, which is minus 6m plus 18, and this is equal to 4, so I will write here 4. Since this thing is the denominator of this term, so I can shift this thing here, and when I will shift here, it will become in the numerator, okay? So I will multiply 6 minus 2m here, okay? So what I will do, I will write this thing here and equal to 4 times this denominator. It is 6 minus 2m. Now I'll multiply 6 inside, 4 inside, 24 minus 8m, and here I have m cube minus 6m plus 18. Then I have m cube minus 12m plus 18, and I will shift this thing here and this thing here. It will be plus 8m minus 24 equals 0. I have shifted 8m, it becomes plus 8m, and 24 was plus. When I shifted here, it becomes negative 24. So m cube minus 12m plus 8m. 12m plus 8m will turn into negative 4m, and then 18 minus 24 will turn into negative 6, which is equal to 0. Yeah, I think I have done a mistake previously. When we multiply this 9 inside, so I will have minus 9m instead of minus 6m. When I multiply this 9 inside, I will have minus 9m and then 9 times 2, which is 18. This is correct, and this must be 9. So this must be 9. This must be 9. This must be 9. And this must be 15m. When this is 15m, so minus 15 plus 8 is 7m. Okay? Yeah, now it's correct. Since this is the cubic equation, in order to solve the cubic equation, we will guess its first root. We will guess a number, which satisfies this equation. For example, if you put m is equal to 0, here you will get 0, here you will get 0, but here you will get minus 6 is equal to 0, which is not correct guess, okay? So if you put m is equal to 1, for example, then 1 cube is 1, so you will get 1 minus m. If m is 1, then 7 times 1 is minus 7, minus 6 is equal to 0, which is again false, because this is equal to negative 12 and this is 0, so negative 12 and 0 are not equal. So this is also false. If I put m is equal to minus 1 here, then here if I put minus 1, so minus 1 cube is minus 1, minus 7 times minus 1 minus 6 is equal to 0. This is, I think, correct, because minus 1, this is minus minus plus, plus 7 minus 6 is equal to 0. Since this is also equal to 0 and this is also equal to 0, so that means this m is equal to -1 is the correct guess, okay? Because it satisfies our equation. So our first root is m is equal to -1, okay? So if you get the first root, then you can use the synthetic division. What's the synthetic division? Synthetic division. By synthetic division, what you have to do, you have to write the coefficient of m cube first, which is 1 here. You know, the coefficient of m cube is 1 here. Then you have to write the coefficient of x square. Since there is no m square here, you will write here 0. Then you will write the coefficient of m, which is -7. So you will write -7 here. Then you will write the constant term, which is -6. Okay? And then this m is equal to -1 will be here. You will shift this 1 here as it is. Then you multiply this 1 with -1. If I multiply 1 with -1, I will get -1, so I will write -1 here. Then I will add these two terms. If I add 0 and -1, I will get -1. Then again you will repeat the same process. You will multiply -1 with -1. You will get +1. And then again you will add these two things. -7 plus 1 is -6. Again you multiply this -6 with -1. You will get +6. Okay? If you add these two numbers, you will get 0. Okay? This is the 0 remainder of this division. Now you get, okay, last time your equation was m cube -7m -6. Now after doing the synthetic division, here you have some numbers. What you will do, you will write first number and 1 power less from here. Since here you have m cube, here you will write m square. Then you will write the next number -1 and then 1 power less than this. 1 power less than this is m, because this is m square and 1 power less is m. Then you will write the next term. The next term is -6. Then you will write 1 less power. So m to the power 0. So that means we will not write. 1 power less than m is the term with no m. Okay. So this is equal to 0. This is the way how we do this synthetic division and write this equation. So your first value of m was -1. And now this is the quadratic equation. So m square minus m -6 is equal to 0. And this quadratic equation can be solved by using factorization or using the quadratic formula. I will solve it by using quadratic formula. Since the quadratic formula for the quadratic equation am square plus bm plus c is equal to 0 is m is equal to -b plus minus b square minus 4ac over 2a. What I'm saying? I'm saying that if this is the quadratic equation, then this is the quadratic formula. This formula is used to solve this quadratic equation. Now we have this quadratic equation and we will use this quadratic formula to solve this quadratic equation. So if you consider this quadratic equation with this quadratic equation, if you compare both of them, okay, and you will find the value of coefficients. Here, any term involving m square is a. So what term involving m square? In other words, what's the coefficient of m square? Since there is no coefficient, we will consider the coefficient of m square is 1. So a is equal to 1. Now look at the coefficient of m, which is b here, but here the coefficient of m is minus. So I will say that b is equal to -1. Here the constant term is c, here the constant term is -6. So I will write c is equal to -6. Okay, so I will use these values in this formula to solve the equation, this quadratic equation, okay? Okay, so m is equal to minus b plus minus b square minus 4ac over 2a. Minus b means minus, what is b? B is minus 1. Since b is minus 1, so minus b will be plus 1. So I will write here plus 1 plus minus b square. Since b is minus 1, so b square will be plus 1. I mean, minus 1 square is plus 1. Then I will write minus 4ac. Minus 4 times a is 1, c is minus 6. Divided by 2a, the value of a is again 1. Now I will use the calculator to solve these things. Plus minus. Minus 1 square is plus 1. Then I will multiply minus 4 with 1. I will get minus 4. So minus 4 times minus 6. Okay. Over 2 times 1 is 2. Again plus 1 plus minus. Now I multiply minus 4 with minus 6. I will get plus 24 over 2. Then plus 1 plus minus 24 plus 1 is 25 divided by 2. 1 plus minus square root of 25 is 5 divided by 2. Then we have two values, 1 plus 5 by 2 and 1 minus 5 by 2. We have 1 plus 5 is 6, 6 by 2 is 3. 1 minus 5 is minus 4, minus 4 by 2 is minus 2. So I have two answers, 3 and minus 2. So we have two values of m, 3 and minus 2. The one value was minus m and the other two values of m were 3 and minus 2. So the possible values of m are minus 1, 3 and minus 2. Okay. Since m is equal to 3 has been considered previously, because in the start we made two cases and we have assumed that if m is equal to 3 then the system has no solution. Okay. Since m is equal to 3 has been already considered, so I will not consider this anymore. Okay, so I will consider only these two values of m. Okay, since the solution is x comma y, which is what? We have found the solution in terms of x and y. Here it is. X and y are given this value and this value. So x comma y is equal to these values. But we have two possible values of m. Okay, so m is equal to minus 1 or m is equal to minus 2. So first, if m is equal to minus 1, then xy will be, I will put here minus 1. So minus 6 minus 1 square over 6 minus 2 minus 1, comma, here I will also put m is equal to minus 1 plus 2 over 6 minus 2 minus 1. If I solve these values, I will get minus 6 plus 1, which is minus 5, 6 plus 2, which is 8. And here 1 plus 2 is 3, and this is again 8. So this is the solution if m is equal to minus 1. We have the other value also if m is equal to minus 2, because -1 and -2 had not been considered. So we will consider m is equal to -2, and I will put this m is equal to -2 here again. So here in place of m, I will put -2. Then I will solve these values. -6 plus 4, because square of -2 is plus 4. So -6 plus 4 over 6 plus 4. Again 2 plus 2 over 6 plus 4, which is actually -2 by 10 and 4 by 10. In other words, we have -1 by 5 and 2 by 5. So these are the two solutions. These are the two possible solutions for the system. Okay, let's look at the graph. So we have three different cases, so we will make three different graphs. So first I will make the graph for m is equal to -2. Since you have three different equations, so what you will do, you will put m is equal to -2 in all of these equations. So for example, here I will plug m is equal to -2. So, and here I will also plug m is equal to -2. So it will become +2. Here I will also plug -2. So these are three different lines. If you draw these three different lines using the GeoGebra, if you make the graph of these three lines using GeoGebra, they will intersect at some point. Since for m is equal to -2, the solution is -2 by 10 and 4 by 10. -2 by 10 and 4 by 10 is somewhere here. So that means you will have three different lines. They are intersecting at this point. Okay. I don't know these are the correct graphs, but you can use GeoGebra to make these three lines, because this is one line, this is another line, this is another line. You will have three different lines. Okay, you will put these values, these lines in the GeoGebra, and you will get three different lines. They must intersect at this point. Okay, now I will look at m is equal to -1. If m is equal to -1, then here everywhere I will put -1. So -1y means -y. Here m is equal to -1 means -m will be +1, and here also minus. Now if you put these three lines, these three equations in GeoGebra, then what will be the solution? I have found for m is equal to -1, the solution is -5 by 8 and 3 by 8. So -5 by 8 is somewhere here and 3 by 8 is somewhere here. So here is the solution. Here is the point where all three lines are meeting. For example, one line may be here, one line may be here, and the other line may be here. The correct solution is found by GeoGebra. The third line will, must pass this point also. So these lines can be made by using GeoGebra or Desmos graphing calculator. We have third case also. What's the third case? The third case is if m is equal to 3, which we have considered previously in very start of the of this video. So what will happen if m is equal to 3? I'll put here 3, and here also I will put 3, and here I will also put 3. So if you make the graph using GeoGebra of these three lines, you will get no point, because for m is equal to 3 there is no solution. For example, if you get one line here, the other line will go parallel to this. The third line will also go parallel to this. So you will get these three lines which will not intersect at any point. This means no solution. So this is the whole geometric insight of the system of linear equations.